Hello and welcome to our second video on data science. In this video, we will be discussing the different types of data and measures of central tendency and variability used in descriptive statistics. Statistics is the science of collecting, analyzing, and interpreting data. In data science, statistics is a critical tool used to make sense of large, complex datasets. By applying statistical methods, data scientists can identify patterns, trends, and relationships in the data that might not be visible otherwise. Statistics is divided into two main branches: descriptive statistics and inferential statistics. DS refers to the methods used to summarize and describe the characteristics of a dataset, while IS involves making inferences about a population based on a sample. Descriptive statistics includes measures of central tendency, such as mean, median, and mode, as well as measures of dispersion, such as range, variance, and standard deviation. Descriptive statistics also involves graphical methods, such as histograms and box plots, to visualize the data distribution. Inferential statistics involves making predictions and drawing conclusions about a population based on a sample. This involves hypothesis testing and estimation, where data scientists use statistical tests to determine the likelihood of an observed effect or relationship occurring by chance. In this video, we will cover a comprehensive overview of descriptive statistics. Descriptive statistics is an essential tool used in data science to summarize and describe the characteristics of a dataset. It helps data scientists to gain insights into the dataset and communicate their findings to others. Descriptive statistics includes measures of central tendency, measures of dispersion, and graphical methods. Measures of central tendency are used to describe the center of the data, while measures of dispersion are used to describe the spread of the data. Graphical methods, such as histograms and box plots, are used to visualize the data distribution and identify patterns and outliers. Data visualization is an essential part of descriptive statistics because it helps to present the data in a way that is easy to understand. By using descriptive statistics, data scientists can identify trends, patterns, and other features of the data that may not be apparent at first glance. Types of data. Understanding the different types of data is critical in determining which descriptive statistics are appropriate to use and how to interpret the results. There are 4 types of data: nominal, ordinal, interval, and ratio. Nominal data is categorical data that has no natural order or ranking. Examples include gender, nationality, and eye color. For nominal data, the mode is the only measure of central tendency that can be used. Ordinal data is categorical data that has a natural order or ranking. Examples include education level and income bracket. For ordinal data, the mode and median can be used as measures of central tendency. Interval data is numerical data that has no natural zero point, and the difference between any two values is meaningful. Examples include temperature in Celsius or Fahrenheit. For interval data, the mean, median, and mode can be used as measures of central tendency. Ratio data is numerical data that has a natural zero point, and the difference between any two values is meaningful. Examples include height, weight, and age. For ratio data, all measures of central tendency, mean, median, and mode, can be used, as well as other descriptive statistics like variance and standard deviation. Understanding the different types of data and which measures of central tendency are appropriate to use is essential in accurately summarizing and interpreting data. Descriptive statistics plays a vital role in data science by providing insights and communicating findings in a way that is easy to understand. 1. Measures of central tendency. Measures of central tendency are used to describe the average or typical value of a dataset. The most commonly used measures of central tendency are mean, median, and mode. A. Mean. The mean is the sum of all values in a dataset divided by the number of observations in the dataset. Mathematical formula. Mean equals sum of all elements. Number of elements. Programming example in Python using NumPy. Import NumPy as NP. Data equals 2, 3, 4, 5, 6. Mean equals np.mean. Data print mean. Output. Mean 4.0. Real-world application. Mean is often used in market research to determine the average age, income, or education level of a group of people. B. Median. The median is the middle value in a dataset when the data is sorted in ascending or descending order. Mathematical formula. If n is odd, median equals middle element. If n is even, median equals middle element plus next element. 2. Programming example in Python using NumPy. Python. Import NumPy as NP. Data equals 2, 3, 4, 5, 6. Median equals np.median. Data print median. Output. Median 4.0. Real-world application. Median is often used in income surveys to determine the middle income level of a group of people. C. Mode. The mode is the most frequently occurring value in a dataset. Mathematical formula, none. Mode is determined by counting the occurrences of each value in the dataset. Programming example in Python using SciPy. Python. From SciPy import stats. Data equals 2, 3, 4, 4, 5, 5, 5, 6. Mode equals stats.mode. Data print mode, mode.mode 0. Output. Mode 5. Real-world application. Mode is often used in customer satisfaction surveys to determine the most common reason for customer dissatisfaction. 2. Measures of variability. Measures of variability are used to describe the spread or dispersion of data. The most commonly used measures of variability are variance, standard deviation, range, and interquartile range. A. Variance. Variance measures how far the data is spread out from the mean. It is calculated by squaring the difference between each value in the dataset and the mean, summing these values, and dividing by the number of observations minus 1. Mathematical formula. Variance equals sum of squared differences from the mean. Number of elements. Programming example in Python using NumPy. Import NumPy as NP. Data equals 2, 3, 4, 5, 6. Variance equals np.var. Data doc equals 1. Print variance. Output. Variance 2.5. Real-world application. Variance is often used in financial analysis to measure the risk associated with an investment. B. Standard deviation. Standard deviation is the square root of the variance. It measures how spread out the data is from the mean. Mathematical formula. Standard deviation equals square root of sum of squared differences from the mean. Number of elements, or, in a simplified version, standard deviation equals square root of variance. Programming example in Python using NumPy. Import NumPy as NP. Data equals 2, 3, 4, 5, 6. std_dev equals np.std. Data doc equals 1. Print standard deviation std_dev. Output. Standard deviation 1. 5811388300841898. Real-world application. Standard deviation is often used in quality control to measure the variability of a product or process. C. Range. Range measures the difference between the largest and smallest values in a dataset. Mathematical formula. Range equals maximum value, minimum value. Programming example in Python. Data equals 2, 3, 4, 5, 6 data underscore range equals max data, min data print range, data underscore range. Output. Range, 4. Real-world application. Range is often used in sports statistics to measure the difference between the highest and lowest scores. D. Interquartile range. Interquartile range measures the difference between the 75th and 25th percentiles in a dataset. Mathematical formula. ICR equals Q3, Q1. Import NumPy as NP. Data equals 2, 3, 4, 5, 6 Q1 equals NP dot percentile data, 25 Q3 equals NP dot percentile data, 75 ICR equals Q3, Q1. Print interquartile range, ICR. Output. Interquartile range, 2.0. Real-world application. Interquartile range is often used in medical research to measure the spread of data in a patient population. 3. Measures of distribution. Measures of distribution are used to describe the shape of the data distribution. The most commonly used measures of distribution are skewness and kurtosis. A. Skewness. Skewness measures the asymmetry of a dataset. A positive skewness value indicates that the dataset is skewed to the right, while a negative skewness value indicates that the dataset is skewed to the left. Mathematical formula. For a sample, skewness equals 3, mean, median, standard deviation. For a population, skewness equals 3, mean, median, population standard deviation. Program from SciPy import stats. Data equals 2, 3, 4, 5, 6 skewness equals stats.skew data print skewness, skewness output. Skewness, 0.0. Real-world application. Skewness is often used in finance to measure the asymmetry of stock returns. B. Kurtosis. Kurtosis measures the peakedness of a dataset. A positive kurtosis value indicates that the dataset has a sharper peak and heavier tails than a normal distribution, while a negative kurtosis value indicates that the dataset has a flatter peak and lighter tails than a normal distribution. Mathematical formula. For a sample, kurtosis equals sum of x, mean 4, number of elements, 1, standard deviation to the power of 4. From SciPy import stats. Data equals 2, 3, 4, 5, 6 kurtosis equals stats.kurtosis data print kurtosis, kurtosis output. Kurtosis, minus 1.3. Real-world application. Kurtosis is often used in finance to measure the risk associated with an investment, as a high kurtosis value indicates a higher likelihood of extreme outcomes. 4. Measures of association. Measures of association are used to describe the relationship between two variables in a dataset. The most commonly used measures of association are correlation and covariance. A. Correlation. Correlation measures the strength and direction of the linear relationship between two variables. A correlation value of 1 indicates a perfect positive correlation, a value of -1 indicates a perfect negative correlation, and a value of 0 indicates no correlation. Mathematical formula. R equals sum of x, mean of x, y, mean of y, square root of sum of x, mean of x2, sum of y, mean of y2. Programming example in Python using NumPy. Import NumPy as np. X equals 2, 3, 4, 5, 6y equals 1, 2, 3, 4, 5 correlation equals np.grcofx, y0, 1 print correlation. Output. Correlation, 1.0. Real-world application. Correlation is often used in marketing to measure the relationship between advertising spend and sales. B. Covariance. Covariance measures the directional relationship between two variables. A positive covariance value indicates a positive relationship between the variables, while a negative covariance value indicates a negative relationship. Mathematical formula. Covariance x, y, equals sum of x, mean of x, y, mean of y, number of elements, 1. Programming example in Python using NumPy. Import NumPy as np. X equals 2, 3, 4, 5, 6y equals 1, 2, 3, 4, 5 covariance equals np.covx, y0, 1 print covariance. Output. Covariance, 2.5. Real-world application. Covariance is often used in finance to measure the relationship between two stocks in a portfolio. 5. Hypothesis testing. Hypothesis testing is a statistical method used to determine if there is a significant difference between two groups or variables in a dataset. It involves making an assumption about the population parameter and then using sample data to test the validity of the assumption. A. Null hypothesis. The null hypothesis is the assumption that there is no significant difference between the groups or variables being tested. B. Alternative hypothesis. The alternative hypothesis is the assumption that there is a significant difference between the groups or variables being tested. C. P-value. The p-value is the probability of observing the sample data or more extreme values, assuming that the null hypothesis is true. A p-value less than or equal to the significance level indicates that the null hypothesis should be rejected. D. Significance level. The significance level is the level of risk that the null hypothesis is rejected when it is actually true. The most commonly used significance level is 0.05. Mathematical formula. The mathematical formula for hypothesis testing depends on the specific test being used. Some commonly used hypothesis tests in data science include t-test, used to determine if there is a significant difference between the means of two groups. T equals mean of group 1, mean of group 2, standard deviation of the difference between the groups, square root of the number of elements in each group. ANOVA, used to determine if there is a significant difference between the means of 3 or more groups. F equals variation between groups, variation within groups. Chi-squared test, used to determine if there is a significant relationship between two categorical variables. Chi-squared equals observed frequency, expected frequency squared, expected frequency. From SciPy import stats. Group 1 equals 2, 3, 4, 5, 6. Group 2 equals 1, 2, 3, 4, 5. T underscore statistic, P underscore value equals stats.tist underscore in group 1. Group 2 print T statistic, T underscore statistic print P value, P underscore value. Output. T statistic, 2.2360. P value, 0.0441. Application, Hypothesis testing is commonly used in healthcare to determine if a new treatment is significantly more effective than an existing treatment. In summary, descriptive statistics are an essential part of data science, as they allow analysts to gain insights into a dataset and communicate those insights to others. Understanding the mathematical formulas and programming examples for common descriptive statistics is crucial for any data scientist. Real-world applications of these statistics include finance, marketing, healthcare, and more. Thanks for watching. If you enjoyed this video, please don't forget to like and subscribe to our channel for more content like this. And if you have any thoughts, questions, or suggestions, please leave a comment down below. We'd love to hear from you.